Hello everyone, welcome back to my channel. This is Stacy. I'm very excited to do LeetCode with you guys. Today we're going to look at number 200 question, number of islands. So let's start by looking at the problem. In this problem, 1 is land, 0 is water. And if we connect adjacent lines horizontally or vertically, we will get an island. What we need to do is to find how many islands in this grid map. For example, here the top left 4 1 in yellow are connected together. That's the first island. The green one is an island by itself. The bottom right 2 1 in red are connected together, so that's the third island. As a result, there are 3 islands in this example. If we break down the problem, the input is a 2-dimensional grid map. In the algorithm, first connect adjacent lines to island, then count the islands. Finally, we return the number of the islands. We are going to use depth-first search, DFS, to solve this problem. First, let's review what is DFS. So DFS is an algorithm to traverse tree or graph. It starts at a node and explores as far as possible. Now that we know what is DFS, let's look at how we solve the problem. Let's look at this example first. We start from the top left one. There is no number on the top or left, so we go to the right to the second one. For the second one, the left is the one we already visited. No number on the top. To the right, there is 0, which is water, so there is only one way we can go, which is bottom. Then we are here at the third one. The top one is the one we just visited. The right and the bottom is 0, so we go to the left one. At this one, we visited the top and right one. There's no number on the left. The bottom is water that we can't go. So it turns out this is the furthest one we can go from the start original one. So at this point, we connected these 4 ones in yellow together, which means we connect the 4 adjacent lines to an island. The same process applies to the green island and the red island. Let's review the process again. On what condition we start our DFS algorithm? Here we start from this point. Here we start from this point. And the third island we start from this point. Obviously, whenever we have a 1, we start our DFS algorithm. Now the question is how we find all the ones in this 2-dimensional array. That's right, we use 2 for loops. If we find a 1, we start our DFS process. When it comes to DFS, we usually use recursion to implement it. It's very important to figure out what's the stop condition for the recursion. If we recall what we just did, whenever we find a point that is not 1, we stopped. Also, since it's an array, whenever we access a number to check if it is a 1, we need to do the boundary checking first. The third issue we have to solve is how to avoid duplicates. There are 2 kinds of duplicates. The first is avoid traverse duplicates. For example, here, the top one we already visited, so we shouldn't go to the top again. This requires us to find a way to differentiate the ones we have visited and the ones we haven't. The second thing we need to avoid is duplicate results. For example, from this one with DFS, we get the island in yellow. From this one with DFS, we can also get the island in yellow. That will give us duplicate results. So how do we avoid both duplicates? Here we are using a common trick, which is mark 1 as a point sign after visiting. Let's look at how this works. First, we visit the top left one, then we mark it as a point sign. Then we go to the right, to the second one. There is no number on the top. The left and right are not equals to 1, so we go to the bottom one. Then we mark the second one as a point sign. Come to the third one. The top, right, bottom are not equals to 1, so we can only go to the left. And we make the third one as a point sign. Finally, come to this one. The top, right, left, bottom are not equals to 1, so there is no way to go. This is the last one. We also mark it as a point sign. At this point, we connect adjacent lines as an island. We also mark all the ones as a point sign. This not only avoids duplicate traverse, but also avoid duplicate results, since the next one in the array is the green one instead of the yellow one as before. Now that we solve all three issues, let's look at the solution together. Let's look at the main function. First, we initialize result as 0. Then we use two for loops to traverse the array. If we get to a point that equals to 1, we start our DFS algorithm. When we get to a point that cannot go further, we will backtracking to this point, which means we found an island. Then we increase the result and continue the for loop to find the next one in the array. Finally, we return the result, which is the number of islands. Now let's look at the DFS function. The stop condition is whenever a number is not equals to 1. But be sure to do the boundary checking before access a number, which is when I is less than 0 or I equals or greater than the row number, or j is less than 0 or j is equals or greater than the column number. If that's the case, we will stop the DFS and return here. If that's not the case, we will mark the 1 as a pound sign here, and then continue the DFS, which is go to the top, right, left, and bottom. Next, let's code on LeetCode. First, main function. Initialize result as 0. Then two for loops to traverse the array. If the number equals to 1, we start the DFS process. And then increase the result. Finally return. The DFS function. The stop condition. If the number is not equals to 1. But remember to do the boundary check. Then mark the number as a pound sign. Finally, continue the DFS. We run and submit the code. It is accepted. Last step, let's review what we learned. We use two for loops to traverse the array. If there is a 1, we start our DFS process. As for when do we stop in the recursion, it is when we have a number that is not equals to 1, or we get to the boundary of the array. Finally, to avoid duplicates, we use a trick to mark 1 as a pound sign after visiting. Last but not least, let's look at the complexity analysis. The time complexity is OMN, where M is the number of rows, N is the number of columns. It is because we avoid duplicate traverse, so that each number of the array only traversed once. As for the space complexity, the worst case is also OMN. We all know when we use recursion, there is extra space needed to store the current status. So the worst case is when the grid map is filled with lengths, where DFS goes by MN deep. Alright, that's all I have for you today. Thanks for watching. This is Stacy. I'll see you in my next video. Bye!